Let's talk about some inscribed angles. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. An intercepted arc consists of endpoints that lie on the sides of an inscribed angle and all the points on the circle between them. A chord or arc subtends an angle if its endpoints lie on the sides of the angle. Let's look at what these mean. Angle DEF is the inscribed angle. Notice the vertex is on the circle. Arc DF is the intercepted arc, because you notice that ED or angle DEF opens up to arc DF, right here and right here. Arc DF subtends angle DEF. So inscribed angles mean the measure of them is half of its intercepted arc. So if arc AC is 100 degrees, we know that B would be 50 degrees. This is when one of the segments of the angle go through the diameter, or go through the center, goes around the center, or don't even go around it at all. These are three different cases in which you have inscribed angles. On your note card at this time, make sure that you write the phrase central angle, same as arc. Inscribed angle, half of arc. So central same, inscribed half. Let's look at some examples. We're going to find the measure of angle PRU, which is this angle right here. Well, if you notice, let me get a different color here. If you notice, here's the angle. It intercepts arc PU. So, and the vertex of the angle is on the circle. So this is an inscribed angle. So we know that the measure is going to be half the measure of its intercepted arc. Which then we know that the measure of angle PRU would be 59 degrees. Let's take a look at the measure of arc SP. Arc SP is this arc right here. If you follow from P to the vertex, S to the vertex, they meet at angle R. The measure of this angle is 27 degrees, so we know we have to double the angle in order to find the measure of the arc. And we get that the measure of the arc would be 54 degrees. So now I want you to do this one for class. Make sure to have your map pencils or highlighters, copy the picture down, and highlight the angle and the arc as necessary. A little corollary says that if inscribed angles of a circle intercept the same arc or are subtended by the same chord or arc, then the angles are congruent. If you notice, angle ACB, ADB, and AEB all intercept arc AB. Since they all intercept the same arc, all three of these angles are congruent. So let's take a look at this picture here. An art student turns in an abstract design for his art project. We need to find the measure of angle DFA. Lines can get complicated, but you notice that we know this angle here, which we can use. We also know this arc here. Well, if you follow this arc, we get an inscribed angle BDC. Well, if we know that the whole arc is 164, the measure of angle CDB would be half of its intercepted arc, which we get is 82 degrees. Well, if you notice, we're starting to form a triangle here. So I'm going to draw triangle DFC. Ooh, because you love my drawings. We know this angle is 33 degrees, and we just found this angle to be 82 degrees. Well, if we remember that there's 180 degrees in a triangle, the measure of angle CFD, we take 180 and subtract out 82 plus 33, which we then get that this would be 180 minus 115, which is 65 degrees. So we know that this angle here is 65 degrees. If you remember, we're trying to find this angle. We know that these two angles here are a linear pair, which makes them supplementary. So all we have left to do is to find the measure of angle DFA is to take 180 minus 65, and we get that the measure is 115 degrees. These take practice getting used to seeing, but if you notice, you look at what you're given. Here we looked at the intercepted arc of the inscribed angle, and we went step by step from there. This is why highlighters and matte pencils are important. So now I want you to take a look at this string art design and find the measure of angle ABD and the measure of angle of arc BC and have it ready for class. We have another theorem that says an inscribed angle subtends a semicircle if and only if the angle is a right angle, which should make sense since this inscribed angle intercepts a semicircle, which is 180 degrees. Half of 180 is 90, so it would be a right angle. So here, if we want to find the value of A, we got to look at our picture. Notice WY is a diameter, so this arc is 180 degrees. If we're trying to find this angle, we know that it's going to be half of 180, which makes it a right angle. So we have 90 equals 5A plus 20. And we should get that A is 14. So just take a look at what it intercepts, decide if it's an inscribed angle, and then take half of that to get the measure of the inscribed angle. Now I want you to take a look at this picture and find the measure of angle LJM. It will be due in class. I want you to do this one as well and have it ready for class. Let's take a look at this one. We want to find the measure of angle EDF. So this is the measure we want to find. Well, if you notice, the angle here intercepts arc EF. Well, if you look at angle EGF, this angle also intercepts arc EF. So since they intercept the same arc, we know that the measure of angle EDF should be equal to the measure of angle FGE. So now we can substitute in our values and solve for x. We can add our 2x, subtract our 3, divide both sides by 4, and we get that x is 18. So the measure of angle EDF, when we substitute in our 18, gives us 39 degrees. We need to make sure to check our answer, so we're going to substitute into the measure of angle EGF and make sure that we get the same thing. And in this case, we will also get 39 degrees. So we just checked our answer to make sure that we were correct. There's another theorem that says if a quadrilateral is inscribed in a circle, so this quadrilateral has its 4 vertices on a circle, then its opposite angles are supplementary. So we know here that angle A plus angle C equals 180 degrees, as well as angle B plus angle D is equal to 180 degrees. Let's look and see how we can use this. We want to find the angle measures of quadrilateral GHJK. Well, they give us 3 of the 4. As long as we have opposite angles, we know that they are supplementary. So we know that 6B plus 20 plus 3B plus 25 equals 180 degrees. And that comes from angle J plus angle G equal to 180. So we can combine like terms and solve for B. Now we can go back and find all the missing angles, or all the angles. Angle J, 6 times 15 plus 20. Which we can check and then do angle G, do these check out to be 180? Yes, they do. So you know that we did it right. So now we need to find the measure of angle K. And then since angle H doesn't have any measurements listed, but we do know it's opposite angle K, so we can do 180 minus angle K to get that it is 99 degrees. And if we go through and add all 4 of these up, they should add up to 360 degrees. Please take a look at this one and find the angle measures of J, K, L, and M. Remember that if you are having any trouble with any of these, please come see me in tutorials. Any of the theorems in the boxes in this video you may add to your note card.